When solving an OR inequality, while you are presented with two situations, each one will be solved completely independently of each other until the last step, in which we'll combine the solutions on our graph or using interval notation. We're going to solve the left-hand one in purple to indicate that they are both different and independent equations. We'll start by subtracting 4 from both sides, resulting in negative x is greater than or equal to negative 3. Remember to be careful with your signs. Lastly, we have a negative x, and we'd like it to be positive. So we will divide by negative 1. Remember, there is a 1 in front of that x. You just can't see. That cancels out the negative signs. And on the right-hand side, we have negative 3 divided by negative 1 is a positive 3. Just be careful to remember that when you divide by a negative, the direction of the inequality switches. In this case, from greater than to less than. We've solved the first inequality that is part of the OR statement. Now let's take a look at the second. We'll do this in blue to indicate that it is an independent equation. In order to solve for x, first add 3 to both sides, and lastly divide by 6. Oh, there we go. X is greater than 5. Now recall, this is an OR inequality. So x could be less than or equal to 3 or greater than 5. That is my solution set. To write this in interval notation, we have to write the union of two intervals. The first interval, as this is less than negative 3, starts at negative infinity and ends at positive 3. Infinity, whether it is positive or negative, always gets a rounded bracket, and the equal sign under the inequality statement indicates that we use a square bracket for the 3. This is the union of two intervals, so I will put in the U for union. If you're typing this, it's fine just to use the traditional U on your keyboard. And then the second part, greater than 5, means from 5 all the way to infinity. Notice the rounded bracket used for the 5 due to the fact there is no equal sign underneath this inequality statement. Lastly, we can go ahead and graph this by creating a number line with our endpoints on the number line. And realize that while our first endpoint, 3, gets a square bracket, and our second gets a rounded bracket. And when we shade, in this case, we do not shade in between them because we are saying x may be less than 3 or to the left of 3 or greater than 5 or to the right of 5. Okay? This is your expression solved both in interval and graphical notation. Again, please see the video for graphing in Microsoft Word for steps on how to present a graph on your discussion board post.